Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogba Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. So in this lesson, we want to look at an additional problem or three additional problems under implicit differentiation. So from previous lesson, we said whenever you have an equation where x and y are mixed up and y is not the subject of the equation, then that means that that equation is an implicit equation. But if y is the subject of the equation and on the other side of the equation is just in one variable, it means that it is an explicit equation. So we want to look at question 5, 6, and 7. The first one says x squared plus 2xy plus 3y squared equals to 2. So remember we told you whenever you differentiate y, you must attach its derivative or notation, that is y prime or the y by the x. So we are doing that because y is the name of the function. So if x was the name of this function and the independent variable here was y, we would have attached the x by the y to this x. But traditionally, x is most times the independent variable and y is the dependent variable. So y most times take the name of the function. So let's find its derivative. So x squared is equal to 2x. We are now differentiating. And then for this case, we have to use the product rule because we have x and y combined. So we hold this 2. We hold x and differentiate y. That's a product rule. Product rule say hold the first one, differentiate the second one. So the derivative of y is 1, but we attach y prime. Plus, we hold this y now and differentiate x. The derivative of x is just 1. So we don't need it already. Then we come to this 3y squared. It just gives us 3 times 2 is 6. I just write the entire thing. 6y prime equals the derivative of 2 is 0. So we can further simplify. We have 2x plus 2xy prime and then 2y. So this is plus 6y prime equals to 0. So what is our objective? Our objective is to ensure that y is the subject of the equation. So we have to solve for y. First, we put y on one side of the equation, all the terms of y prime on one side of the equation, and then all of the terms with x, put them on the other side of the equation. Not x now, but the ones without the y prime. So we put them on the other side of the equation. So we can now factor out this y prime. So we have 2x plus 6y prime equals. Now on this side we have 2 and 2. So we can factor out negative 2. We're left with x plus y divided by, so we can divide this out by 2x plus 6y. But on this side we can just factor out this 2 because it's the same. Factor out this 2, left with 2. Let's say x plus 3y. So this 2 and this 2 can cancel out. This and this go out. You have y prime now to be equal to negative x plus y all over x plus 3y. So we can call this our final answer. And then we'll move to the next problem. So the next problem says x minus y cubed all over y plus x equals x plus 2. So we can get rid of this denominator by multiplying all sides by y plus x. So y plus x times the first term, y plus x and this y plus x will cancel. You just be left with x minus y cubed. And then y plus x times this term will be x plus 2. Or we just multiply, right? Let's just multiply. So it's x times y is xy, and x times x is x squared. 2 times y is 2y, and 2 times x is 2x. So now we have not started differentiating yet. We were just trying to simplify the problem. Now let's find its derivative. So we're differentiating every term now. The derivative of x is just 1. The derivative of y cubed, remember, you drop the power, y squared. So please, if you have some issues with the different rules, the power rule, the quotient rule, the product rule, the chain rule, please check previous videos so that at least you have an understanding. Please, the videos are within the playlist, so they are not difficult to get. You just check the previous videos, and they are arranged lesson by lesson, so the lessons are all in order. So we have, since we differentiated this y cubed, we must attach y prime because it's the name of the function. X, y. So we now have this product rule. We hold x and differentiate y. We get 1, but we must attach y prime. Plus we hold y now and differentiate x. We get 1. So there's no need, right? Move to x squared. The derivative of x squared is just 2x plus the derivative of 2y is just 2, but we must attach y prime. The derivative of a constant goes to 0. Now we must ensure that all of the terms with y prime are sent on one side of the equation. So this is minus 3y squared y prime minus x y prime and minus 2y prime. This side you have 2x plus y, and we send this term across, it becomes minus 1. Y prime, y prime, y prime, we can factor it out. This is minus 3 y squared minus x minus 2, and y prime is out. So this is 2x plus y minus 1. So what we can do, we divide both sides by minus y squared minus x minus 2. On this side, we can factor out the negative. So when the negative comes outside, you have 3 y squared plus x plus 2. Because negative times every term here gives you these expressions. So finally, we can have y prime to be negative 2x plus y minus 1 all over 3y plus 3y squared plus x plus 2. So we can call this our final answer, right? We call this our final answer. And do the last problem. So the last problem says y over x cubed plus x over y cubed equals to x squared y to the 4th. So what can we do? We can get rid of these two denominators by finding their LCD, which is x cubed times y cubed. So x cubed times x cubed y cubed times the first x cubed and x cubed we cancel. You'll be left with y cubed. So multiply this, multiply by this expression is y to the 4th. And then this time this x cubed, let's say y cubed cancel. So this becomes x to the 4th. And then x to the 5th. And then this becomes y to the 7th, right? Great. Now we can find our derivative. The first one, we have 4y to the 3rd and then we attach y prime. Plus, in this case, we say 4x cubed. We cannot attach x prime here because x is the independent variable. X is not the name of the function. It is a variable within the function. Equals, for this area, we must apply the product rule because we have two variables being multiplied. So we hold the first variable, which is x to the 5th, and we differentiate y to the 7th, which is 7y to the 6th power times y prime, plus we hold y to the 7th, and we differentiate x to the 5th. We get 5x to the 4th. So we can now simplify and show that y prime is on one side of the equation, and the other side of the equation are all other expressions. So this term with y prime, this term with y prime, we must send them on one side. So we have 4y cubed y prime minus 7x to the 5th y to the 6th y prime equals, this is 5x to the 4th y to the 7th. So we send this 4x cubed across, it becomes 4x cubed. So we can factor out this y prime. We're left with 4y cubed minus 7x to the 5th y to the 6th, and then y prime is outside, all equals to 5. Now, x to the 4th power, x to the 3rd power, let's factor out x to the 3rd because it's common to the two of them. Times this 5x y to the 7th minus 4 divided by, so we can divide both sides by 4 y cubed minus 7 x to the 5th y to the 6th. Do the same on this side, but between y and x, let's say between y to the 3rd and y to the 6th, we can factor out y to the 3rd so that we don't keep writing the same thing. So it's now 4 minus 7x to the 5th and y to the 2nd, y to the 3rd, because we took 3 from within the 6, so we're left with the 3rd power. So finally, we can have y prime equals x to the 3rd 5x y to the 7th minus 4 all over y to the 3rd 4 minus 7x to the 5th y to the 3rd. So this is actually our final answer for this problem. So thanks ever so much for watching. See you in our next lecture. Thank you. Please don't forget to subscribe to our channels and watch our other videos so that you understand the previous lessons before jumping into implicit differentiation. See you guys.